Hello everyone, what if the CPU always picks the shortest task first? The simple idea can reduce the waiting time dramatically, and it is called the shortest job first scheduling. In this video, we will understand SJF scheduling with the real life examples and the numerical problems. So guys, SJF stands for shortest job first. The process with the smallest CPU burst time is selected to run next. SJF aims to minimize the average waiting time of the processes, and SJF can be preemptive as well as non-preemptive. Imagine a hospital with one doctor. Patients with the small problems like headaches are treated first before the patients needing the surgeries. So real life example could be taken as your operating system, where patients are actually working as your processes. Treatment time is the burst time, doctor is actually the CPU, and the order of services is the scheduling. So guys, SJF works the same way. Shortest job is served first. So we have seen there are two types of SJFs, that is preemptive as well as the non-preemptive. So guys, in a non-preemptive SJF, once a process starts running, it continues until it finishes. But in the preemptive SJF, if a new process arrives with a shorter remaining time, the running process is stopped and it is replaced. Okay, so preemptive SJF is also known as the shortest remaining time first. Now guys, let's solve one example using the non-preemptive SJF. We are being provided with the processes, the arrival time and their burst time. Okay, so here we have to select the shortest job among the arrived processes. So at time 0 only P1 was available, so we have to run P1. Okay, now at time 7 P2, P3 and P4 are also available. So we will choose the process with the shortest burst time, which is P3. So now the order will be, first of all, the P1 process is going to execute, then P3, then P2 and then P4. Okay, so I have shown the Gantt chart here. So guys, in case if we want to calculate the waiting time, okay, so we know waiting time is the start time minus the arrival time. Okay, so for process 1, your start time was 0 and the arrival time was also 0, so the waiting time was 0 only. Then for P3, 7 minus 4 it is 3, for P2 it is 6 and for P4 it is 7, and the average waiting time would be 4 units. So guys, SJF gives you the lower average waiting time as compared to your FCFS. So now we will take one more example of the preemptive SJF, which we are calling as the shortest remaining time first scheduling. Again, we are being given the processes, the arrival time and the burst time. Okay, so guys, in your preemptive SJF, at every time unit, the CPU select the process with the shortest remaining burst time. So that means if a new process arrives with the smaller remaining time than the current running process, then the CPU is preempted. Okay, so here guys, we'll see the step-by-step scheduling. At time 0 only P1 was available, so we are going to run, that means the CPU is going to run the process P1. Remaining time of your process P1 is 7. At time 1 P2 has arrived and the burst time was 4. Okay, so as compared to your process 1 where the burst time was 7 and the process P2 has the burst time of 4, so the CPU is going to choose P2. Okay, so P1 will be preempted. So now at time 2 again P3 arrives, so burst time is 2, which is lesser than your process P2. So CPU is going to choose P3 and going to preempt the process P2. So at time 3 P4 arrives with the burst time 1. Okay, so comparing P3 and P4, so your CPU is going to choose P4 and it is going to finish P4. Now we will see the remaining time of P3, P2 and P1. P3 was having the remaining time of 1 burst time, P2 is having 3 and P1 is having 7. So again the CPU is going to choose the process 3. Okay, so at time 5 P3 will finish. Again it is going to compare the remaining two processes, that is P2 and P1. Again it is going to choose P2, and finally at time 8 P2 will finish, and the remaining again it will be choosing process P1. At time 15 P1 also finishes. I have shown the Gantt chart over the screen. So now guys, we'll again going to find out the waiting time, which is the turnaround time minus the burst time now. Okay, so or your waiting time could be your finish time minus arrival time minus the burst time, since your turnaround time is the finish time minus the arrival time. Okay, so finish time we are knowing that for P1 it is 15, for P2 it is 8, for P3 it is 5, and for P4 it is 4. We have calculated the waiting time as shown on the screen, and the average waiting time is 2.75 units. So you can see that preemptive SJF gives even the lower average waiting time than your non-preemptive SJF. So preemptive SJF makes the scheduling decisions at every arrival of a new process. Okay, it requires the continuous comparison of the remaining burst time. This increases the context switching overhead. Okay, but guys, since we have seen that the average waiting time has been reduced in your SJF, but the main problem with the SJF is the starvation. Okay, so if short processes keep on arriving, okay, so long processes may never get the CPU time. So for example, in the hospital, surgery patients may keep waiting if the small cases keep coming. Okay, so starvation means indefinite waiting of the longer processes. So guys, in the last, let's summarize. Your SJF is providing you the minimum average time. Optimal scheduling algorithm it is, okay, but it is difficult to know the burst time in advance, and it can result into the starvation problem. Guys, let's discuss some of the important interview questions from this topic. So what is the main goal of SJF? The answer is to minimize the average waiting time. So what is the difference between FCFS and SJF? Answer is FCFS selects by the arrival time, SJF selects by the shortest burst time. And what is preemptive SJF called? Preemptive SJF is actually known as the shortest remaining time first scheduling algorithm. Last question is, what are the main disadvantages of SJF? So the main disadvantages of SJF are starvation and the burst time prediction problem. In the next video, we will learn priority scheduling, which controls the execution based on the importance. So guys, follow this OS series to master your CPU scheduling step by step.